Hey everyone, this is Christoph with another episode of ScaleYourCode.com where proven developers teach. And I've got a question for you. Have you ever built or used an API before? I'm willing to bet that most of us have. From Facebook to Stripe, most of us have either had the pleasure or the pain of using an API. And I say pain because not everyone builds APIs that are fun to work with. And so today, Phil Sturgeon is with us to talk about building APIs the right way. See what I did there, Phil? I had to be clever and combine the two titles of your books.
Nicely done. Nicely done.
Building APIs you won't hate, and I know you helped write PHP the right way.
Yeah, a bunch of it.
And so it seems like, a lot of companies want an API nowadays, and a lot of developers are working on them right now. And so that's where we're going to spend most of the time talking about. And by the way, this isn't just for PHP APIs. These concepts apply to other languages as well. But I'm also going to ask Phil a few questions about things like the new PSR standard, dependency injection and namespace, tools he uses to push code live, and also if he has any exciting news in the PHP world. Since I know you're a respected figure in the PHP world, I figured I'd ask you that. So Phil, it's great to have you on the show.
Yeah, thanks for having me.
So Phil is currently a senior developer at Ride, and he previously founded PyroCMS, which is an open source CMS. And he was also part of the CodeIgniter core team. He helps host a show called PHP Town Hall, and is also a member of PHP-FIG. So can you tell us a little bit about what PHP-FIG and what you guys do?
Yeah, sure. Actually, I've recently moved away from the PHP-FIG.
Oh, okay.
Which wasn't, I didn't do a lot of news about that, but basically the Framework Interoperability Group is a group of framework developers originally, then it moved to being lots more people that run content management systems or just high-level packages like Guzzle. But they're all different PHP projects that we're trying to work out, instead of everyone kind of rebuilding the same thing over and over again and usually building them in ways that wouldn't really work with each other or talk to each other. They wanted to try and find commonalities, starting with things like auto-loading, moving on to code style and getting into logging and other things. Just ways they could work together to decrease the amount of kind of repetitive stuff they were doing.
I got you. And you're the guys who came out with the whole PSR auto-loading, right? And everybody kind of started using that because of it. So why did you move away from it? Is there a reason why? Or?
Nothing big or interesting, to be honest. PyroCMS, you mentioned, that company was actually acquired from me back in July, which was a really nice birthday present for me. The guy that took it over was fine with me staying on the FIG, because I've remained a technical advisor for PyroCMS, and I will be for a while. But he was okay with me staying on the FIG to represent PyroCMS for a while, because we were still working on some active PSRs. They're the kind of standards that we make, like RFCs or whatever. So because I was still involved with them, I didn't want to just leave those halfway through. But then eventually one was done, and the other is taking such a long time to do that I just said, you know what, I'm going to have to step aside now anyway. And someone else is taking it over, so it's okay.
That makes sense. Can you tell us a little bit about Ride and what it does?
Sorry. 1 second, I've got a light here and it's going mad. 1 second. Sorry about that.
No worries, no worries. So I was saying, can you tell us a little bit about Ride and what you guys do or are going to do?
Yeah, so Ride is a carpooling company. Sounds a little bit similar to Uber, I know. We do actually have the same CTO that Uber used to have, so that's a nice similarity. But carpooling is all about, I go to work on this day and this day at this time, and I want to share that journey with somebody every single time I go to work, pretty much. So match my itinerary, find me someone that lives nearby, and then we can all drive to work and save money and save the environment and whatever else.
Okay, and do you guys have a product out yet, or are you still working on that?
Apple is currently reviewing it, and it should be out within a couple of days, hopefully. So that will be exciting.
And I know we had to reschedule this interview because you had some issues with debugging, or at least you emailed me and you said, you know what, there's a lot of bugs flowing in. I think we're gonna have to reschedule. Can you tell us, about 1 or 2 bugs that maybe might interest the viewers?
I had some really it was a really silly thing. I built an autocomplete system because it's a service-orientated architecture. So the iOS and the front end things just kind of call off to that separate service, right? It didn't need to be an API. It wasn't really a big enough thing. So the one bug that was holding people up quite a lot was that they couldn't find cars that they were searching for. You type in Audi and it'd come up with like Saturn Acura or something. It's really bad. It was due to the Elasticsearch mode, the search mode that I'd been using, which would allow. The requirements were it should be case insensitive, allow partial words, allow words to be out of order, but it should also allow for spelling mistakes. So I used a fuzziness of 2, I believe, which would allow words to have 2 mistakes in them. Okay. But that meant if you typed in a word that was 4 letters long, like Audi, and the vehicle had AU in it, then that would be enough. So there was all these crazy bugs like that, and I kept going through, and I asked for a list of all the requirements of all the expected searches that should work and the vehicles they should do, and I put them all into a big old pile of unit tests in my Go app, and I was trying to find like one single Elasticsearch mode that would allow all of them, and in the end I just hacked it. I used a multi-match for Elasticsearch, and I indexed all the vehicles. They have to be searchable by make, model, year, and fuel type. So I just did like 10 of these input fields that would do make, model, year, make year, model, make, and just did them in different orders each time, which is a complete hack. But it meant that it works perfectly fine, and that's good enough for now. So I'll be revisiting that soon as I've got my PhD in search algorithms.
So why Elasticsearch? Is that the only viable product right now that does this kind of thing?
No, I mean, it seemed like a good idea at the time, and now it's too late to change it.
Right.
Elasticsearch is good. I've heard people talk good things about Solar. There's a few different search tools around. I've never had extensive experience with any of the search systems. I've always got by with MySQL, full text search, and I think a lot of developers do. So I didn't really know where else to go. Elasticsearch seemed good, and I'm not entirely sure that I'll be with it that much longer. But for now, it gets the job done, and it's the most trivial part of our system, so it shouldn't really be so. It shouldn't be such a time suck. I've got other features to make.
Right. What's the main difference between something like a full text search in MySQL and this kind of service like Elasticsearch or Solar?
It's a tricky one. With Elasticsearch, it's like a whole engine for different search-based algorithms. So there is kind of fuzzy matching, there's full text searching, there's prefix searching, where prefix search is all the characters have to be in the correct order from left to right, and things like that. So there's so many different kind of modes of search that it can do pretty much anything. You can even do regex searches, but I just couldn't find one that would allow case-insensitive, partial matched words to be out of order with a reasonable number of spelling mistakes, but not so many that you type in a 4-letter word and you get the wrong word. So that was a nice little delve into Elasticsearch. But
yeah, I have a friend that's trying to start a project, and he was thinking about using Elasticsearch because it's a whole searching engine or sharing links, that kind of thing. And that's why I'm asking the questions. We talked about this before air, and I figured, well, I'd throw in a few of those questions in. But let's go ahead and start talking about your API book. And the first question I want to hit you with is, what gave you the idea to write this book? Why did you go with an API book?
I wasn't really trying to write a book or anything like that. I know it's kind of popular right now for everyone to write a book, but I started off, I think I was working with a lot of different APIs at the time. I was integrating with Facebook and Twitter, and I've worked extensively with YouTube and Dig and just every single API you can think of. And there were a lot of things that really annoyed me about working with them. Working with so many as I had, that it really kind of stuck in my craw a little bit. So I wrote this kind of joking, a little bit ridiculous, but it was a very much like Eat Your Greens article about all of the things that you shouldn't do and some of the things that you should. And it was just kind of a slightly sweary, silly article, but it was just a kind of a bullet point list. And people were like, wow, that's a whole lot of things. I hadn't really thought about some of those things. Could you explain them more in maybe in blog form, like a series of blogs? So I started doing that, and I did one about database seeding, and I got onto kind of endpoint naming theory. And each one, there was 2 choices in how I was going to do this. It would have been a 14-part series either way, and I could have done them I could have just kind of smashed them out as blog posts kind of quick, and it would have taken me a couple of months, but it wouldn't have been as good as it could have been. Or I could have spent loads of time on them and got one out a month, and then that would take me a year and a half to finish all the articles. And I just thought, if it's going to take me a year and a half and I'm going to write it properly, I might as well release this as a book and get some money out of it.
That makes a lot of sense to me.
Yeah, I mean, I feel like being paid for it was the incentive to actually make it higher quality. It wasn't just some mercenary
Right,
thing. It's
right.
like, if
Good
I'm
point.
actually selling this, I have to make this proper instead of just kind of throwing something out there.
That's a good point. And I got your book. I actually got it. I think it was back in December. I went through Lean Pub and decided, you know what, I'm going to buy some of these books. This is going to be a good year for reading this kind of stuff. And then I interviewed Steve Corona a few weeks ago, and he said you should really interview Phil. And I looked
Nice.
you up, and I'm like, wait a minute, I have your book. So I quickly went through it. I hadn't even read it yet, but I went through it and I started reading it, and I'm like, this is fantastic. This is some really good stuff. So with this interview, I really want to break down the major steps in building the API process that you cover in your book, so that listeners can walk away from this interview and know the general idea of what it takes to build, a fast, resilient, secure API. And but right before we do that, can you please tell me what RESTful really means? There are so many different people saying so many different definitions. Can you please tell us what it means?
Right. So RESTful is a phrase that's thrown around a lot. And so first, there's the term REST. REST is a specific architectural style done by Roy Fielding, who did it as a PhD a whole while ago. And REST is a generic architecture which can apply to any sort of network. And it's really quite vague in some ways and very specific in others. These days, it's used almost exclusively to describe HTTP APIs. And there's a lot of confusion in that people think that REST is specifically tied to HTTP. It's not. People think that pretty much any HTTP API that uses like get, post, and put is a RESTful API.
Mm-hmm.
So there are a lot of APIs that misuse the term REST, and therefore that confuses people. It's ended up becoming like this badge of honor that means that if it's RESTful, then it's good. And because people really want that badge of honor, they kind of ignore what it actually means to be RESTful just so they can have that and feel like their API is good.
Yeah.
So it's a very confusing thing. But RESTful usually just means like, oh, we've got some of the REST principles, but not all of them, which is strange.
And I was really surprised to see that in your book, actually, where you talk about some of the Google APIs or Twitter APIs where they're not really matching the RESTful stamp like you were talking about, but they still call it RESTful. And so that ties into what you were saying about that. All right, so let's start with the first steps in developing an API. And in your book, you start out with theoretical work. We're not actually coding just yet. So what do we start with? Do we start with the database design? Do we talk about the application design? What are the first steps you usually take?
So the first step for me is usually to work out the database, because your API is going to be talking to data somehow, and that could be a database, a classical SQL system. It could be Mongo if you really want to. It could be other third-party APIs and services. So at Ride we have messaging and billing and all these other different services that it's talking to, as well as just the local Postgres database. So working out your kind of data, working out your architecture, and then moving on to working out your actual specific database structure is the first couple of steps, because otherwise you don't know where anything's going to go. And if you the database design itself doesn't really matter. It doesn't need to be fully normalized. It doesn't need to be like Mongo stuff's fine. You can use ORMs if you want and swap those out later. I find that using an ORM is really helpful for kind of rapid application development. And when you're trying to get things done, it's much easier to tweak things if it's an ORM. And then you can kind of look through your slow query log later and replace it. So don't try and optimize it before you need to by making everything like a stored procedure or something, because you'll never finish the API.
Okay, and in that way it's faster to pivot, like you said.
Yeah.
All right, so we have the database. What next? Are we talking about endpoints then?
Nearly. You have to fill up your database with useful data. Okay. This is a really important step. If you're using pretty much any language you're using, there's a tool called Faker. Everyone's ported it to every single language. It's in Perl, Python, PHP. It's everywhere. You can use tools like Factory Girl for Rails, for Ruby, sorry, or you can use Factory Muffin for PHP. And all these tools, those sit on top of Faker and make it really easy for you to throw fake data in there. You want to seed your database with at least a couple of hundred records in pretty much every table. So a few hundred users, a few thousand places if you're doing a venue check-in, stuff like that. Otherwise, you're only developing against like 4 or 5 rows that you've manually put in the database. And that is a really bad way to build an API, because you don't notice how slow things get when there's only 4 records.
That's a good point, yeah. And then after that, that's when you start doing the endpoints?
Yes, absolutely.
What do you mean by endpoints?
One of the biggest toss-ups that people have trying to work out, should we do everything singular or everything plural, or like plural and singular? So people always obsess over users v user. You know, and you have users could get you all the users, and then user slash Dave gets you that one user. That doesn't really work out very well when you have words like opportunities, which is opportunity, and people, which is person. So if you try and mix plural and singular, then the English language will catch you out. So just make everything singular.
Okay.
And you can have collections, which are all of the things, or a subset via pagination. You can have resources, which are the collection slash identifier. And then you can have sub-collections. So it'd be users slash Dave slash photos, and that would be another collection. And then those should just link off to another collection or another resource.
Okay, so if we have everything singular, if you want to get one user, you'd do like user slash Dave, or if you want all users, you'd do something like user slash all or something like that, or just user slash.
Just straight up users.
Just straight up user. Okay, I got you. All right. So we've got the database now, and so we know what the controllers and models and routes are going to look like, and we just talked about the endpoints. Is it time for inputs and outputs yet?
Yeah. So yep, you got to work out your content type. So once you've got the endpoint, that's kind of like the address for the resource. But resources, they need representations. So a big part of REST is about having representations that aren't necessarily the same as the resource itself. So you can have a JSON representation. You can have any data type you want. Mm-hmm. A lot of people just stick with JSON these days because it does the trick. You can use YAML if you want, whatever. A lot of people still want to use XML. It might be a requirement for your business. I try and avoid XML unless you specifically are told you have to support it, because trying to auto-generate XML from an array of data or from a collection from the database, it can be quite hard. If you just throw XML into an auto thing, there's no way for you to distinguish between attributes and actual properties. Mm-hmm. So you end up in this weird, like, I have to make view files now, and that's a whole extra layer of junk you don't really need. But work out what data formats you need, and don't restrict it to just JSON or other data specifically. You can have images too. Okay. So uploading JPEG and PNG and stuff like that should be perfectly valid. So don't create code that assumes it's always just JSON.
Mm-hmm. And that's one of the things where if I can avoid XML, I'll always try to go with JSON instead.
Absolutely.
I've had so many problems with XML. It's a pain. I wish it just go away. So then what are some important things to remember when dealing with HTTP requests and responses? And I know that's a pretty broad question. So starting with HTTP headers, what kind of things do you want to look for when talking about headers?
So one tricky thing with headers is that most people assume they are key and then value, and there's just a single value. With HTTP headers, you can actually, with content types, for example, you can say the content type might be application/JSON, and then it might have a semicolon, and then say char set encoding equals UTF-8. Okay. So never do like exact string matches. Find yourself a tool that can parse HTTP headers properly, especially if you're working with content types and accept types and things like that. So there's a good one for accept headers called Aura accept in PHP world.
Okay.
But never do like direct string equals on headers because you don't know what you're going to find in there.
All right, let me actually drag. I've got a screen here. I'm going to drag on the screen so people can see it. You probably can't see it, but this is just an example from your book, actually, where it shows one of the headers, and you can see here is post/check-ins, HTTP. You got the host here, the authorization, which I think we're going to talk about a little bit later. And then this is the content type he was talking about, where you have the application/JSON, and then this was what the content inside would look like. Drag that back out. All right, so then we have the HTTP headers. And I just showed the HTTP content structure, and you just mentioned it as well. And so I also pulled the Twitter style and the much namespace nice output out from your book. Off the top of your head, what are some of the pros and cons between using something like the Twitter style or Facebook style response, or something like much namespace nice output? Why do you want to have which is a nice name, by the way. But
Yeah.
why does that matter? What's the difference with that?
So designing the actual message, the representation of the resource is actually a pretty difficult job. If you look at pretty much any API, they're all completely different. If you look at Google and YouTube, YouTube has this idea of snippets where you can just request one snippet and you get a little bit of data, or you can request like more of it and there's a whole bunch more data and they're all in subsections. Or you look at Twitter and they just throw a collection in there and you just have an array of things coming back.
Yeah,
or you look at Facebook and they embed it in data. There's lots of pros and cons to all of them. Since writing the book, and I'm probably going to go back and add to that section quite heavily, I've recently adopted the JSON API standard, which the name makes it sound way more official than it really is. It's just a standard for how you should format your JSON. But it covers things like how to do a collection, how to do metadata, how to send back one single resource, how to list and embed other relationships. And the pros and cons of all of them are quite excessive. But one of the main troubles, if you don't namespace your responses, it can be really hard to put other related data in there. Namespacing responses just means you, instead of just sending an array of items back when you have a collection, you put them in a data, or you put them in a tweets, or you put them in some sort of namespace. If you don't do that, and you just send back an array, and then you're like, oh, I need to include pagination data in there, you can, because you just have an array, and then there's nowhere for it to go. So yeah, Facebook, or the much namespace, nice output approach that I've used in the past has been fairly helpful, because not only does it show you what information is in the response, because you have that namespace as an identifier, but it means that you can sideload other included data and relationships, and you can add metadata next to it as well.
Okay, and just so you know, I've got this pulled up on the screen right next to you so people can see it, where there's data here, and then you have name, Phil Sturgeon, ID, some ID, and then you have a comments, and inside that comments you have an array of data with an ID, text, that kind of thing. And so then you could add in pagination and all that. So, all right, that's fantastic, awesome. But so up to this point, we're assuming everything's working fine. But obviously that's not always going to happen, right? You're going to have errors and status codes, that kind of thing. Should you standardize errors? Like, how do you deal with errors? Like 404s or just bad requests, that kind of thing?
Absolutely. So I always try to use an appropriate status code, as you should. So you never, ever, ever put errors in a 200, because I've seen people doing that. And if you put error messages, people sometimes differentiate. They assume that error is more like exception, like an error is something really bad that happened and there's some major problem. But and then they separate out errors and validation. So validation still means like, oh no, nothing's really broken, but your email address is formatted wrong. And they have errors and validation and success very separate. So everything's an error. If something isn't working as expected, if you're not going to accept the data, that's an error. Okay, so the error could be bad formatting, bad broken syntax in the JSON. It could be that's not an email address. All of these things can either be, I always forget the exact code that we use, but they can always be like 400 bad request, or they can be 422 if you want to get kind of weird about it. But use status codes. But if you download the program called Dash, they have them all listed down in great detail, or just search for like HTTP status codes and use the one that seems the most appropriate. But don't rely on just that error code. So you want to add to your response, instead of just having the status code, you want to supplement that response with a piece of JSON. Just put errors and then an array of errors, because there can be more than one, and put what they are. And those errors should have a few different things. They should have a sort of error code, which could be a number or a whatever string. And that code is a specific, unique code to that problem. So if I have a quick look, I'll probably find a few on here. If you give me one moment.
Let me see. I may even have some pulled up. Let's see.
Hang about. So I have this massive errors.yaml in my code. And it's got loads of things in here. And it's got things like unauthorized. That's got... So I'm laughing a little bit because these messages in here are great. I sent them off to my copy guy, and it's like, whoa, pump those brakes. You don't have permission to access this resource. But each one has a code and a message, and these codes can be arbitrary. So I separate them out. So each different resource has a different like area of numbers. So things like 11,001 is all generic validation errors. So 11,002, all of these things are generic validation. This is not a float, for example. Go on further on, and there's account-specific ones, and that says, hold up, this account is inactive, and that's 12,001. Then 13,000 is all about addresses, and I just separate them out like that.
Okay.
So we have a code, and we have a message. That means that the computer can work out what's going on, and the human can work out what's going on. Some APIs only give you a human-readable message, which means that you have to do like string position index of like substring matching on the actual message that you get back just to work out what to do next, which is terrible. And some APIs only give you a code, and then you have to go and run off and work out what that code means on their website. So give them a code and a message for humans and computers, and then put a URL to the position in your documentation that explains exactly what that error message does.
And this reminds me, I was trying to do something on PayPal just a few days ago, and I think I was registering a new account with a different email or something like that. And I'm going in to register, and everything's working fine. I'm on the last step. I hit sign up, and there's just an error that pops up. It says, sorry, that didn't work. Please try again or contact support. And I'm thinking, well, maybe this is for security reasons because it is PayPal, but that is the most unhelpful error I've probably ever seen.
Absolutely. You see them pop up a lot, and it's really annoying. That's usually because some 500 happened, and 500s usually happen when the developer has been a bit lazy. They haven't. It can happen to anyone, whether you're lazy or not. But 500s are kind of they usually trigger like something broke. So that's one of the things you should do. Yeah, when you're building your API, if anything's going badly, it's going to end up with a 500. You always have to keep an eye on what 500s your API is returning, because they're usually catching a bug in your code. Now, this might not be terrible, because usually a 500, as long as you've got your kind of errors and your exceptions turned off for production, a 500 error is just going to go.
Yeah.
But if it could be a problem that is in your code that you need to look at. So yeah, always watch out for those.
Can't 500 errors also be something wrong with the server, like the web server or something like that? Like isn't there a 502 bad gateway or
Pretty much, yeah. 500 itself, there's a whole bunch of them, and I can't always remember the codes off the top of my head. But some of them, I think 503 is the load balancer. It doesn't have any servers to talk to. There's no active servers left, right? Like servers gone away kind of message. So some of these things can be network problems. Some of the 500s are network problems, but a 500 usually, more often than not, is an application error. Or it can mean like your web server is misconfigured, or there's like a git merge in your nginx config. But usually it's the kind of the API, the application that's just fallen over, because a really common example of 500s is that someone's using an ORM and they've said, find user by ID 5. And there isn't a user 5 in the database. They forgot to check whether that's a valid response or not, and they've tried to use a method or a property on that user. And instead of having an object, they've got a null or a nil, and it's just gone, can't do that. So that's a really common one. Whenever you find a 500 like that, you wrap that with a little line of code that throws a proper error message, and then you write a test for that and show that it works now.
Okay. So I feel like this is a pretty good point to move on to testing your APIs. And in the book, this is the next step anyway, so it's perfect. But how are we going to test if we don't even have any code yet? Because up until now, we're still doing theoretical stuff, right? So I know there's a lot of talk about test-driven development where you're writing the test before you even move into the code. Can you tell us why that's a good idea?
Writing the code takes a lot of time, and writing the tests doesn't. With the tests that... we can get onto the specific tools in a second, but with most tools, I suppose, you're just saying, here's a URL, here are the parameters I expect to send to you, and this is the response that I expect back, right? And that's a nice way. You can just write those really quickly, and that does a few things. You can show those tests to your mobile developers, your API users, and say, does this work for you? And that's a lot quicker than running off and building the entire thing and then them saying, oh no, that doesn't work for me. So there's quite a few ways that you can actually build that. And one of them, one of them is I use something called API Blueprint,
Okay.
and that is a markdown-based system which you kind of write your resource groups. So a resource group is like users or check-ins or whatever, and then resource actions are create user,
Hmm.
place make a check-in, those sort of things.
Okay.
So you kind of separate the code out, and then then you can put in, this is the URL. Here are the parameters that are going to go into this. Here is a default value for this parameter. Here is a example request body and any headers that are going to go with it. And here is an example 200 response. Here's an example 401 response. Here's an example of a few other things. So you write that, you just make one big API blueprint markdown file, and then you can use various different tools. There's one called Agilio, which is a complicated name. And there's another one called API-ry, which is by the same people that made API Blueprint. And that is a hosted website. And either way, you've got this markdown. You can use that to make documentation just with one single command that you run, or you just click save on the website. And then you have these tests. Then you have this documentation that you can pass to other people. If you're using that tool, then you can also use something called Dread, which actually run integration tests against your API. So it looks at all of those things. It looks at the URL, it looks at the parameters and their default values, puts those values into the URL, takes the request body that you've placed in there, and throws that at the API server that you have running locally. And then it checks the response. And if the response matches what you put in the documentation, that test pass. And it goes through all of the tests in there and works kind of one at a time. So before you write really complicated integration tests, it's sometimes quite nice to just write the documentation first and then turn that documentation into very basic integration tests. And then you can pass that documentation around, and you can give it to all of your users that are going to be using it and say, does this work for you? And then you can make changes to a single markdown file and just change some JSON around. And then if they like that, then you say, right, we're doing it this way. This is locked down now. And then you just run off and build that and fill in the gaps.
So do you think this kind of approach to building an API is more for builder kinds of APIs that are going to have a lot more users or features or that kind of thing? Or do you really think anybody building any size API should be using something like this?
Pretty much anything. I mean, whatever API you've got, all the services at Ride have done it this way. We've all got API Blueprint. We use API-ry, and we all pass the documentation around before we've even built it, just to show off what we're going to do. Because it's a really, the cool thing with API-ry as well is that you can, if you're using API-ry or API Blueprint plus another mock server, you can actually, before you've built it, you can have a mock server. So it will use the example responses that you've got, so that when you actually, it gives you a fake server, like a fake domain that you can hit with the same URL. And when you hit that, it gives you like a static JSON response. So it just throws it back at you. So even before you've built your system at all, your users can actually be, coding against the static response, which for all intents and purposes is the same thing. It works perfectly fine. So it's a perfect way to approach things regardless of how big they are. I've done it for a autocomplete service that has 2 endpoints, just because it meant that I can confirm that that's a format that they want. It means that they have documentation of how it works already. They haven't got to wait for me to finish it after I finally release the product. And it means that I've got some really basic tests before I've even written any other integration tests for my application. So it works really well.
Okay, cool. Do you have any books you recommend that talk about this kind of approach apart from your own?
No, that's why I wrote one.
Yeah.
I was looking through a lot of this stuff, and there wasn't a huge number of resources around. Martin Fowler is a great person on this topic, and he has got a lot of stuff about REST. Apart from that, Mark Nottingham is also an interesting source. He's on the IETF and is responsible for a lot of HTTP specification related stuff. So those two people are very in the know. Troy Hunt has also got a few good blogs out. He did one that I really like called API Versioning. All your versioning is wrong. And it goes through every different approach to API versioning and why all of them are terrible. Yeah. That's a fun article.
Okay, cool. I'll check them out. Thanks. All right, so we've got our tests. Is it finally time to start coding now that we have all this stuff behind us?
Yeah, do it.
So it should, I mean, technically speaking, you don't have to think about all this stuff anymore. You already have it on paper. Like you said, documentation, tests, the database is seeded, all that. So you just already know what you have to code. It's just a matter of sitting down and actually coding it, right?
Yeah, from that point, you just grab your favorite framework, make it respond to the correct route, send it off to a controller, look in your database through any means you feel like using, ORM, whatever,
Mm-hmm.
and then spit out some JSON. That is one part that we haven't got to yet. And the spitting out the JSON or the spitting out the data in general is something that people usually overlook. A lot of developers will get their data. Once you've done the whole route to controller to fetch data,
Mm-hmm.
they think just spit it out. And most frameworks allow you to just return an array or return an object, and it will just convert it to JSON for you. That is very dangerous. If you are simply returning your database results, then you can quite often show off fields that you don't necessarily want to show off. Someone can add a field which contains a secret token that you need to use for confirming your email address or something. And if you add that field to the database and you're just returning the entire database, then that field that was meant to be secret is now completely available to the public. So to avoid doing that, which is really common, it also means if you yeah, it's really common. I've seen this in so many APIs. The other trouble is that if you're trying to build two versions of an API, and versioning is a big topic, but we won't get into it. But if you have version 1 and version 2 of the database, and then you decide to rename or restructure a field or split something into two tables, then you've still got the V1 code base looking at that same database, and you've just renamed a field. So you're just kind of throwing all those fields out there, and then guess what? You've broken your V1 app. So the solution to this is serialization. Imagine the same thing when you build applications in any other sort of application with a user interface. You have a view which takes your raw data and then outputs it in a way that your user expects, right? That exact same thing can be done with serialization. So there are loads of tools for this. I can't remember all of them off the top of my head, but in PHP, I made one called Fractal. There's also JMS Serializer. Ruby has one called Active Model Serializer. It's part of the whole Rails stack. There's also one called RBuilder, I think, or JBuilder. There's quite a few of them around. Search for data serialization and you'll find it. But these things, they all basically take input, they take some data, usually a user model, or usually a model if you're using an ORM. And then they give you either a transform method where you can kind of build the data you want or in an array format, or you just kind of list properties that you want to take out, and then it will just look at the model and take those properties out. Or if there's a method named a certain way, it will do that. So you can kind of fake properties by calling the method instead. But basically it allows you to construct the data in a certain way that you want it to be represented. And you can only show the fields you want, you hide the fields you don't want. And if you rename something, then you just change the serializer to look for the old name, but still, output it in the way that you want.
Okay, I see.
It's quite hard to describe that stuff. I'm usually saying that during a talk, and I've got a slide that I can just point to.
Right. Not as easy here, but I'm able to follow. Hopefully, everybody's able to follow. I'll try to add some either some pictures or descriptions below the video as well to help out. But speaking of showing too much data, and this moves on to the data relationship section of your book, where for some reason I found this section really interesting, where you're trying to reduce the number of HTTP requests, but you don't want to load too much data at the same time, right? Because then that could be really slow to fetch all the information, and then you've just got so many different fields in the array to cycle through, right? So gigantic for loops or whatever you're using. So how do you find that sweet spot? What do you keep into consideration when trying to find the sweet spot between either loading too much information at the same time or splitting it into too many HTTP requests? Are you talking about looking at your audience is having mobile phones, or are they on desktops with faster networks? What's the process behind that?
It's really hard. One of the most important things is that you allow the client to request how much data they want back. So the first most obvious thing is just you set a limit on pagination, so they can say, I would like 7. But when you get to data relationships, it's really complicated. I've had troubles in the past at my last job where the iPhone developer was demanding that we put certain nested data inside so they wouldn't have to make so many requests. But then in certain cases, when you'd have resource A would always include resource B, but then on another screen he'd say, oh, well, resource B always needs to include resource A. So we'd end up with this circular system where it would just go chunk and it would just unlimited nest these things until the server broke. So that's a problem you want to avoid. You want to make sure it's flexible when you can include resource A should have resource B in it or next to it. The other problem is making too many requests is bad. Making one request that's really huge is bad. So at Ride, we've got a problem where on login, some of our clients were saying, okay, I would like to get the user information. Here's the username and password. I'd like to get all the user information. I would like to get the current rides that are active, any matches they have for carpooling, their itineraries for when they'd like to go carpooling, and it was just like basically get the entire database. Wow. So we had this one query, and because that's login, you want it to be really fast, right? But on the first, second, and third screens, there was quite a few pieces of data that they'd needed, so they felt like just get the entire database would be a good solution. So you always have to try and find a middle ground. What we've started doing at Ride is we're starting to whitelist the includes that you're allowed to do. So you can include a piece of data and it will go into the response, but you can only include certain pieces of data. That's quite hard to document, and it's not wonderful because there's no self-discovery there, which is another RESTful principle. But allowing the client to select how much data they'd like to pick, and then just making it clear that sometimes making multiple requests is better than making one mega include of doom that will take down the server. And then you make sure you set decent timeouts as well. So we had the default 30-second timeout on our API when we were testing it, and then we realized that was really bad because one process lasting for 30 seconds is taking up a lot of resources that another process could be using. So we've got it down to like 1 second timeout. So I want to make that much lower because there's no way that our API should take 1 second, but for now these things are okay. But yeah, it's always a trade-off. You need the clients to benchmark it, and you have to work with them. And if they've found a really slow query, then you need to go in there and optimize that with a few kind of preloads or eager loads.
By the way, is Ride starting out in a big city, or is it starting out in the whole country as a whole? Because I could see that being more problematic when you're in a city like New York, where you just have so many rides that'd be available for you, right? And having to fetch all this data. But if you're in a smaller town with not as many rides, then you don't have that problem.
Yeah, no, it's rolling out across the whole country, so that's wonderful.
Yeah, I could see that being a challenge. And this goes back to what you were saying about database seeding. If you had just put in a few rows in database, you wouldn't hit this problem until it was too late, until people started using it and actually crashing your servers. And that's a horrible way to go.
Absolutely. Yeah, well, another important thing to do is blitz testing, like, really throwing some traffic at your APIs to make sure they can handle it. And we did that for a while. I used Blitz.io. There's loads of other ones. There's bees with machine guns. There's loads of really great names for these things. But you can give them some requests to do, and you can give them multiple requests. You can have them get and then post and then delete and then do other stuff. Okay. But fill on your staging server or your testing server, fill it with 1 million records. Don't stop at 1,000. Don't stop at 100. 1 million records, and then have it do some things that it seems likely a user would do. Have it browse around through a few pages. Have it search for things. Have it delete and add stuff, and do that for a long time. And then you can just look at your slow query log and find out, oh, I should add an index there, and oh, I should tweak that, or wow, I should really make sure no one can include that URL because that just crashed the server. Things like that.
By the way, are you guys using PHP?
No, Rails.
Rails, okay.
Yeah, Rails, Go, a little bit of Node, all sorts of stuff.
Oh, okay, nice.
Yeah.
Interesting. I was just curious. Going back to, let's talk about debugging now.
Yeah, man.
This is something I really struggled with because it feels like out of the box, something like Chrome or Mozilla doesn't really have the tools necessary to give you a thorough a way of testing what kind of data is being thrown around, that kind of thing. And so sometimes I had to add more code, hack around my code that I already had to see what kind of errors I was getting because it was being hidden depending on the request or, that kind of thing.
Yeah.
How do you get around this?
Yeah, Chrome isn't always the best solution for debugging these things. If you're trying to make the request from the browser, it can be hard. There are a few tools, things like Charles Proxy and Wireshark, that help you at a very low level look to see what's being passed around. So if you're running the API on your local host or a different server or virtual machine, as long as your computer can talk to where the API is, you can use Wireshark just to look at what's coming through. So that's pretty helpful to look at what headers are being set, what responses are being put. But that's a bit more complicated. If you can interact with your API directly, then a good thing to do is to recreate the failing request. Maybe look at the request in Wireshark, take that request down, and then try and interact with it yourself.
Okay.
So to do that, I use Postman. I never, ever, ever debug APIs with curl. People recommend this like it's a good idea. It's really bad. You're there kind of like typing these things, and you're like, method. Oh, that's hyphen capital X. And then you're trying to type a JSON body in there, and you've either got to do it all on one line, and you make a mistake, and you've got to go back and do it. It's horrible. Use Postman. It's amazing. You can build collections. So I've built a RIDE central API collection, and I've added all the URLs in there, and I've added headers, and I've added all the you can add variables in there for like access token, and then update the access token, and you can build up your HTTP request in a really nice way, and then you can run it, and it will show you the response and all the
Lost you for a sec. I don't know if you can hear me or not, but just lost you. There we go. All right, you're back. Welcome back.
So, yeah, first of all, find the failing request. So talk to your iPhone developer and get the actual HTTP request from them, or sniff it out with Wireshark, get it somehow, and then manually recreate it with Postman so that you can recreate the error. Hopefully it's happening locally as well as happening staging or wherever is broken. So Postman is just a Chromium application, not quite an extension. It's like a standalone app, but Chrome. But yeah, once you've got the failing request, you've just got to debug it like you debug anything else. So if that's Rails, if that's Ruby, shove some debugger, pry, bye-bye commands in there to interact with the stuff. If it's PHP, slap in some breakpoints and have your IDE tell you what values there are. Find out what the problem is. As soon as you found out what the problem is, write a test for it, and then you're good to go. It will never happen again.
Awesome. I wish I had that. That sounds a lot better than what I was doing. Could have saved hours of time.
What were you doing, man?
What's that?
What were you up to? What were you doing?
I don't even want to say. Just pulling up the console, looking at what's being passed around. Like I said, I would go in the code and have to change some of the requests sometimes just to see what's going on, because what are some requests that Chrome doesn't even show? Like something like, does it show put, or I'm not even sure.
Oh yeah, there's a few of them.
Yeah, there's a few of them I just couldn't see, and I'm sure there were some ways around it. I just didn't know of them at the time. This was about a year and a half ago or so. But anyway, yeah, I saw one of your posts talking about API documentation, and this is something that I never really thought about. I mean, I used API documentation all the time, but there's so much work that goes into it that I didn't realize. And that's really what makes or break an API. I mean, if nobody can figure out, nobody's going to use it, right? So what do you recommend as a good approach to handling API from the get-go?
So API Blueprint, like I was talking about earlier, and another alternative to that is RAML. RAML's a YAML-based, so RAML is a YAML, YAML, based system. And you just, much like API Blueprint, where you just write kind of text and Markdown and JSON, RAML, you just write YAML code and you put in your statuses and your responses and everything else. The reason I've stuck with API Blueprint is, for now, I haven't looked into RAML enough to know if there's the same tooling around it. The tooling with API Blueprint is crazy. So I mentioned Postman. Some people start with Postman, and that might be a good way to go. You have a list of all of your endpoints, you have a list of all of your requests and responses. That's basically a sort of documentation. So you can start with Postman, or you can start with API Blueprint, and then you can actually import and export both to both. So you can make API Blueprint documentation for your entire API, and then you can export that to Postman. Or you can build the entire Postman system and then export that to API Blueprint. But they both go either way.
That's awesome.
And once you have your API Blueprint, if you then set up Dread, as I mentioned, you can actually, because the API Blueprint file lives in your code repository, If you use pull request based functionality adding in your team, if everyone sends a pull request, then you can hook up Dread to Travis or Circle CI or whatever you use. And if you haven't updated the documentation to match the change that you've just made, then it's going to error and break the build and you can't deploy it. So you can actually make sure that your API documentation is completely up to date just by enforcing Dread usage. And it doesn't work for everything. If you're kind of adding a field, it might not notice. But if you kind of change values or change format or rename the field, it will definitely shout at you. And that's caught me out a few times. So that was a good thing we did.
I see I've got that URL from your blog post on philsturgeon.uk, and it talks about Dread and that. I'm going to go ahead and link that below the video for anyone interested. I feel like that's a pretty interesting topic right there. So.
Yeah, so the documentation around Dread is a bit weak. I had a really hard time getting it working. So I wrote a tutorial about it, and now the API team are sending that tutorial out to other people when they ask for help. So apparently it's fairly good. I don't know.
That's awesome. Good job. All right, so honestly, I feel like we covered a good bit of the API stuff. I know there's a whole lot more that goes into it, like the versioning. That was a big topic in your book. And then there's also authentication and that sort of thing. But I didn't include them in this book because I feel like you can't skim over this kind of stuff. You really have to deep dive into it to understand what's going on with that. So let's move on to talking a little bit about some PHP.
Yeah, man.
And specifically starting with just namespacing. I feel like I don't even remember what version made it so that you could start namespacing in PHP, but I feel like it's moving towards that direction. More and more people are doing it. I'm seeing it in more and more code, and I think that's a great thing. What's your take on it? Is it only for larger projects, or is it for smaller projects too? When should somebody use namespacing like this?
Namespacing is a tricky one. It's really, realistically speaking, your application probably doesn't need to be namespaced itself. The idea of namespacing is to make sure that two classes with the same name don't clash, right? Or two functions. It works with functions just as well. Pretty much any code that you install using, any code you install using Composer that supports PSR0 or PSR4, the autoloading standards, those always come in a namespace. So any code you install from the PHP League, for example, will have league / the name of the package / the name of the class. So if you're installing third-party code, then there's very little chance that your code is going to clash with that third-party code because they usually have the company name as the vendor name or the project name at least. So realistically speaking, your code might not need to be namespaced, but I usually namespace it all under app. It's just a nice knowledge to have my code under a little namespace just in case. And then if some functionality is added to PHP or you install some kind of old-fashioned package that doesn't have any namespaces, then you know that your code isn't going to clash with that code. Right.
And that's one of the things that when I started using Laravel a little bit more, there's a lot of namespacing going on in that, and it just kind of like, I'd be in a file and I'd be working on that file and I'd just see the namespace at the top and it would remind me of where I am. That sounds a little weird, I'm sure, but it just reminds you of where you are in the application, especially when you have a larger application like that. And if you make a plugin or if you bring in a plugin, there's not going to be any clash like you were talking about. So, okay, I see what you mean, yeah. And let's see, what else was I going to ask you about that? Can you explain quickly how dependency injection works? I don't want to spend too much time on this, but I understand that some people still struggle with the concept, and I feel like it's a pretty important concept to understand, especially moving on with PHP. Can you explain how that works and why it's so powerful?
Yeah, so at its most basic, dependency injection, instead of you manually kind of hard coding the name of a class or creating an instance of something or referencing something, instead of you doing that yourself, you just pass the injection, you pass the dependency in. So if I need to talk to logging is a good example. We've got PSR3, right, which is the logging standard. So if in my code, I've built a class which is doing a lot of stuff and I need to log what's happening. If in the constructor or somewhere else in the code was manually specifying the monologue, for example, is a logger. If I specify monologue in there, then my code will only ever work with monologue. And if I've got Monologue configured to send things to some server, when I try and write my tests, then it's going to try and send them off to this server, and that's really annoying. So the idea is, if you use dependency injection, you can pass in, firstly, you can swap out one logger for another, right? If you specify a shared interface that both those dependencies have, then you can pass in any one of those, any implementation that implements that interface. But when it comes to testing, you can pass in fake ones. So if you are trying to talk to, maybe you have a Twitter. I'm not doing this very well. This example will be better. If you have a Twitter class and you want to talk, and your Twitter class needs a HTTP component like Guzzle, for example. Okay. If you're using dependency injection and you pass in Guzzle into the Twitter library, then when you're writing unit tests for the Twitter library, it talks to Guzzle via a property. So it's passed into the constructor, stored in a property, then all of your methods say this HTTP client get. And because it's passed in as a dependency, that could either be Guzzle or it could be a mock of Guzzle. If it's a mock of Guzzle, then we can stub the method that actually goes off to Twitter. It stubs the GET request, and it doesn't actually go off to Twitter. It kind of returns a stubbed response, like a fake response.
Right, okay.
So it's a good way to kind of isolate the test units, the test. I can't use words today. It's a good way to isolate the test from talking to third-party resources, be it database, be it other APIs, or whatever else. And it just means that your code is less hard tied to one specific implementation, but it's more tied to kind of any implementation that fits past that interface.
And I actually pulled up an example from PHP the Right Way, the website. What's the URL? Is that PHP the Right Way? Is it .com or
.com? Yeah.
.com. Okay, so I pulled it from that, and I'll add this below the video. But here's a really quick example with using MySQL adapter, where you have a class called database, and there's a public function construct. In the first example, without using dependency injection, they have inside the construct this adapter equals new MySQL adapter. Whereas in the second example, which is using dependency injection, there's the MySQL adapter is inside the construct instead of being inside of the parameter of the construct instead of being inside the construct itself. And it's such a small change in the code, but then it makes it so much easier to swap out the adapter, to completely change the adapter without breaking the rest of your database class.
Exactly. If you take that a step further as well, and instead of specifically hinting for MySQL database adapter, and you search for and you hint that you require a database adapter, then you could easily pass in a Postgres database adapter or whatever adapter, and it would still work.
Yeah, completely swap it out to something completely different. Could be something local instead of an actual database, something completely different, and it would still work. And I feel like that's such a powerful concept, and for some reason it just took me so long to realize it. I wish I'd listened to this talk a few years ago.
Yeah, it's a tricky one.
Cool. Thanks for explaining that. I appreciate it. All right, so next, what tools do you use to deploy code? Without going into too much detail, I'm just curious to know.
I've used a lot of different things in the past. I used to use Chef for actually provisioning the server, so making sure that Apache was installed and that sort of thing. And it has deployment built in, and Chef's deployment is very similar to Capistrano in a way, where it kind of deploys everything to, if you have var dub, then it will have the git hash of which commit you're deploying, and then it will install all of those in var dub, then the little hash there, and they'll have a symlink for var www/current, and the current will symlink to the actual revision you're deploying, if that makes sense. Yeah. So you'll always have a history of the last 5 deployments that you've made, and the symlink just changes instantly, so it's pretty much atomic, and then that just works. Setting all that stuff up can be really hard, and people always argue over Chef or Puppet or Ansible or Capistrano or whatever these things are. These days, I actually just use Heroku. I've done it for a few freelance projects, and they support PHP perfectly, and it's really just simple. You just git push, and it's up there. If you're worried about running tests before you git push, then you can push it to GitHub. GitHub can ping Circle CI or Travis CI, and then once Circle CI has run all of your tests and made sure everything works, then it can deploy it to Heroku for you. So it's just so easy to just push to a production branch and then have it go to production if all the code works. I'm
gonna have to try that out.
Yeah.
I tried Heroku a while back, and I don't know why I just stopped using it and moved on to something else. But yeah, that sounds a lot easier than some of the other things I've come across.
Yeah, I mean, Heroku is more expensive, but
Yeah.
if you're working for a startup with deep pockets, no. The way that I look at it is Heroku just does so much for you that there is not a lot of point doing it yourself.
Mhm.
I know the developers love to learn
Yes.
new tools. They do, and I really enjoyed it. The last company I worked for, I had to learn Chef. I had to learn AWS, a lot more advanced
Mhm.
than I'd ever done before. I had to learn about elastic load balancers and about kind of auto scaling and all this crazy stuff.
Mhm.
And I had to learn about like optimizing Nginx for
Yeah.
a whole bunch
Yeah.
of stuff. Actually, Steve Corona's book really helped me out there.
Right. Right.
That's how I got talking to him. But I had to learn a whole bunch of stuff, and now I just have to git push. It
Mhm.
took me like 6 months to get this stuff ready. I got the architecture ready. It was auto scaling. It was load balanced. It was in different geographic areas, so it was
Right.
perfectly like
Right.
spaced out. And this all took me 6 months. It cost the company God knows how much of my time to build.
Yeah.
And in that time, I could have been working on more features that would have helped us get another round of funding. You know,
Mhm.
so if Heroku is a bit more expensive, that's fine if you're more interested in kind of writing functionality than you are pretending that you're a sysadmin. But if you have a
Mhm.
sysadmin, then probably you don't need Heroku.
Just out of curiosity, if you had more time and you weren't in a time crunch and you weren't spending the company's money, would you recommend still going that route? Because like you said, developers really want to learn, and if you already had the knowledge, if you already had all that knowledge, would it then have saved the company more money?
Yes, if I'd known exactly how to do it at the time and there wasn't as much of a rush, then going back to AWS would still be a good idea, I think. But
Okay.
it's not so much the basic setup. It was a constant, ongoing sea of problems. And one of the wonderful things with Heroku is that they just have all these integrations for you. So when I finally had the application running perfectly, to get the application running under high load and tested with Blitz only took me 2 months. The rest of those months were how to make really smooth deployments, like seamless deployments where it wouldn't break all the migrations wouldn't take a few minutes in real time. Things like that are pretty hard. Then trying to get centralized logging happening. So I had Logstash running on all those servers and sending them all back to a centralized Graylog user interface. Like all of this stuff, just every single time you try and learn it, it takes time,
Yeah.
and
Yeah.
deploying it takes time, and getting it perfected takes time. And with Heroku, you just click, I would like paper trail. And then you paste in your paper trail API key. And you're like, cool, now I have paper trail. And it just takes no time at all. So
Mhm.
while I'm not suggesting that developers become lazy, what I do think is that it's useful to get these things done via Heroku system first, and then you can kind of play around with taking them out of that and putting them into a more advanced system later on. Maybe do that when you've hired a few more people and they know more about it.
Yeah.
Maybe, I don't know, but I don't think I'd necessarily go AWS again until I had someone that knew a lot more about it than I did.
Mhm.
'Cause even as CTO at the last company, like not everyone could know everything. It's
Yeah. Yeah. There's a lot of stuff in Amazon Web Services. The first time I went into it, I'm like, man, what's going on in here in this dashboard?
yeah,
But some really interesting tools. I always try to mess with them when I have a little bit of time and learn all kinds of things. So, but yeah, I see where you're coming from. That makes a whole lot of sense, especially when you got to launch the product, your time crunch and all that kind of thing. That's very nice.
yeah.
So, in the PHP world, do you have any exciting news for us?
Uh, PHP7 is doing pretty well. PHP7 is currently in feature freeze, but there are a few features that are still pending. So the feature freeze means that no new features can be put to a vote, but there's a few votes still ongoing.
Okay.
And we've got some really cool features coming in PHP7. One of the best things about PHP7 is that everything's becoming a lot more consistent. Now, we unfortunately haven't made any changes to the standard library, so there's still some of the string functions still have underscores and some of them don't, and we don't know whether it's needle haystack or haystack needle anymore. But if you take the standard library aside and ignore that for a moment, which we'd all like to do, everything else is becoming much more consistent. There's things like an AST, so abstract syntax tree, which means that there were certain combinations of things in the past that would work and some wouldn't. Like sometimes you put brackets around something and that would give it different semantic meaning to something that didn't have brackets around it that really shouldn't have happened. So the AST will take out a lot of kind of weird problems. We've removed a whole bunch of, I say we, I'm on the internals team now because I put my name on one RFC. But PHP is getting uniform syntax as well. These things are all quite hard to explain without demos, but it's kind of things like array dereferencing and class dereferencing, and you can have like square brackets and then an arrow and then more square brackets and then function parameters and it just all just kind of works. You can write really ugly code, but it actually works in a perfect way. So the language itself is kind of growing up, and the unexpected behaviors are becoming less and less.
That's awesome.
There's some really cool things. What are the other ones? So now instead of throwing fatal errors, a lot of the time the engine will throw exceptions so you can catch them. So if you call a method that doesn't exist, you can actually catch that as an exception instead of it just falling over. We have return type hints and we have scalar type hints. So instead of just saying it has to be an array or a class, we can say it could be a string or an int or a bool. And you can do that on the return as well. So you can actually specify after the function declaration colon bool, and that will say it's going to return a true or a false. Okay. So there's some really cool features coming for PHP7 that make it a lot more consistent across the board. And I really hope that PHP8 can then focus on replacing the standard library, which is still completely inconsistent.
That's pretty exciting. I'm not going to lie. I really look forward to see what they come out with. I haven't really kept an eye on it that much, but from here on out, I'm going to keep an eye on it. Do they have a date yet on when it's supposed to be released?
If I remember rightly, which I probably don't, it's October 2015. So it's Q4 this year, basically. Okay. There will be release builds out soon. You can already test PHP7. You can download the source and compile it. If you search for Rasmus Lerdorf Vagrant, then he's the creator of PHP, has created a very nice Vagrant box that will install all of the stuff you need to just make PHP7 there. So you can play around with it in there. And Travis also supports PHP7, so you can enable 7 in your build matrix. Whenever you push your code, then it will tell you whether your code works on PHP7 or not. So there are plenty of ways you can try PHP7 now.
Very nice. I think I'm going to look that up and maybe add it below the video. That's interesting. I'm sure other people would be very interested in that, in the Vagrant box and all that. All right, one more question and then I'll let you go. I know this is running a little bit after an hour, and it's just so much to talk about, so much exciting stuff going on right now.
Yeah, well, I've been riding my bike around all day, so sitting down is absolutely fine with me.
Cool, perfect. So what about PSR? What's anything new with that?
Yeah, PSR7 is incredibly close to being complete. Unless, as I said, I've been on my bike all day. I haven't quite checked the results, but it might have already passed. But as far as I know, the vote's got a couple of days left. PSR7 is the HTTP message PSR. So it initially sounds fairly unexciting. What do you think of PSR7 so far? Like, what do you know about it?
Not a whole lot. I'm looking at it right now. I'm trying to see when the if I can see a date on here, but I see PSR7 is imminent, and here's my issues with it. That's everettpot.com. Sure.
Yeah. Well, the last time I looked at the results, the EvertPot is the only person that voted no on it. There's like 20 votes for yes, so we're looking good. But basically, if you work with most of the other languages other than PHP, if you work with Ruby or Python, are great examples of this. They have systems like Rack, which are really awesome HTTP interaction systems. Like they provide request and response objects and loads more things than that. But at a very basic level, you have your request and your response objects. You can read data coming into the request, if that makes sense. So you can read the request and you can build a response in very well constructed OOP ways. PHP doesn't really have that. We have the Symfony HTTP kernel, which is pretty good, but that's how Symfony does it, and that's it's become sort of a de facto standard, but it's not perfect, and not everyone wants to work with it. So PSR7 does roughly the same as some of Rack and some of Symfony HTTP kernel, because the only other solution in PHP so far is you've got these random little functions that are hidden about all over the place. You can set header responses with the header function. You can read headers on the request with, well, you usually shove things into the server magic global variable. Otherwise, you can call like get underscore Apache underscore headers, which only works with Apache. So if you deploy your code to Nginx, the whole thing falls over. So the whole API for request and response right now in PHP is, in my point of view, fundamentally broken. So you either have to use Symfony HTTP kernel, which doesn't do everything, or you roll your own. And that's what everyone's done. You look at Laravel, you look at every framework back to CodeIgniter and Kohana and Zend and Symfony. They've all got their own solutions. So the FIG's job is to fix those things. You know, when we're all doing it our own different way, we come together and find one way of doing as much of it as we can.
Right, right.
So PSR7 is that. And it supports all sorts of stuff. It supports stream responses, which is exciting. And it supports getting headers and getting query parameters, I believe, getting all sorts of values in the body content in a really consistent way. So you don't have to try and work out. So you don't have to try and like run off to these crap PHP methods, and you don't have to use like the framework's exact thing. And it also means we can start to do more exciting things. Like we can have middlewares. If we know that pretty much any framework, any application is going to have these request and response objects in a certain way, we can start to do middlewares which accept a request and then pass it on and then return responses. And things like middlewares can be an OAuth middleware, which will check certain things. Will check the access tokens, and it will check if those tokens are valid, and if not, then it will force back a new response, which is, sorry mate, 401. And if it passes, then it just goes on down the chain to the next one. And you can have things like there's loads of stack things, but I can't really think what they are. But middlewares are going to be incredibly exciting, and they're going to be a very big thing, I think, for PHP. Even though it might take a couple of months to get there. But then every new version of the framework, Slim, Laravel, they've all got middlewares so far. And we're all going to start to see these kind of PSR7 based middlewares rolling out. And every developer is going to have to learn what middlewares are.
Yeah, good. I'm actually on Matthew O'Finney's blog. I think that's how you pronounce it. And he's got a really, really detailed post about this. I'm probably going to add that in there as well.
Absolutely. Yeah.
So I've seen this earlier.
MWOP is the guy in charge. He is the editor of the PSR, so he knows a bunch.
Yeah, from this post, I can conclude that he knows what's going on. I mean, this looks like a really good post, and I was scrolling through it as you were explaining through that, and I could see some of the stuff you're talking about in there as well. And there's all kinds of get status code, get reason phrase, with status, and so that way you have more standards. And yeah, this is really cool. I'll keep this link here and put it up there. All right, well, Phil, thanks a lot, man. Do you have any interview recommendations? Since I got you through Steve Corona, he recommended I interview you. Do you have anybody else you think I should interview?
I can give you some ideas afterwards if you like, but I can't think of anyone off the top of my head.
I don't want to put you on the spot. No worries.
It's okay. It's 11 o'clock. I'm a little tired.
I got you. Plus, after a day of biking, right?
Yeah, I managed to get 70 miles, which is the first time since the snow's let up. So yeah, I'm pretty knackered.
Where do you ride around?
Just Central Park for now. I used to go upstate a lot, but I keep getting caught in the snow and having to hitchhike home wearing like really small plastic shorts. So this time I just stayed local. It made more sense.
I'm in the South. I don't have that problem.
Right,
I don't go biking enough, though. I need to get myself a bike and do that. I used to do it a little bit back in the day, and that was a lot of fun. But
yeah, man.
Yeah, anyway, thanks a lot, Phil. I really appreciate your time. I learned a lot from reading your book, like I said, and just from this interview alone, a lot of gems hidden that I hadn't read through, and some other stuff through your blog that I highly recommend people check out and that kind of thing. But if people want to get in touch with you, how do they do that?
I am at Phil Sturgeon on Twitter. Okay. My website is philsturgeon.uk, and I talk about PHP, APIs, and sometimes turtles. So there's plenty of good stuff on there.
And you have elephants too on your blog, so.
Oh yeah, yeah.
The PHP elephants.
The drunk PHP elephants, yeah, on a canna cider.
All right, I'm gonna wrap it up because I'm starting to crash a little bit here.
Cool.
So, Phil, thanks a lot for your time. Thanks everybody for watching. If you have any questions for Phil, hit him up on Twitter. If you have any questions for me, same thing, Twitter or the contact form on the site. Thank you all for watching and being a part of it. I appreciate it, guys.